My dear students, Assalamu alaikum. I am ABM Moinul Islam, Associate Professor, Department of Mathematics, Rajiv Gupta Model College. Today I will discuss on a chapter of second paper, and this chapter is exercise 9B, and the name of the chapter is acceleration. Okay, now we want to go for that chapter. You know, in this chapter, that is exercise 9B second paper, the name of the chapter is acceleration. Here we use three formulas in this chapter, and already you read this chapter acceleration in physics also, so a lot of similarity in between acceleration of physics and this chapter. There are three formulas. Formula number 1 is V is equal to U plus Ft. V is equal to U plus Ft. Here U is initial velocity, you know, V is final velocity, T for time, and here F is acceleration. But in physics you use A for acceleration, but in mathematics we use F for acceleration. Formula number 2 is S is equal to Ut plus half of Ft square. Here S is a distance covered by the particle, initial velocity is U, and T for time, and F is acceleration. And last formula is V square is equal to U square plus twice Fs. Okay. Just if F is acceleration, then we use plus sign in formula, but if F is retardation, then we use minus sign in formula. Okay. Now we want to go for question number 28. At first we solve this, and then we shall go for example number 3. These two are similar math. In question number 28, a particle starting from rest moves in a straight line, firstly with uniform acceleration F1 and then with uniform acceleration F2. If it comes to rest in time t measured from the beginning after having describe a distance s, then prove that this. That means in question number 28, this is given that one point is A and suppose another point is B. The distance between these 2 points is S. This is given, and a particle moves from A to B, first part with acceleration F1 and last part with acceleration retardation F2. So suppose first part AC, the particle moves with acceleration F1, and the last part, that is CB, the particle moves with retardation F2. At point A, its initial velocity is 0, and we can consider that in time t1, covering distance s1 with acceleration f1, the particle comes at point C and obtain velocity v. After that, the particle moves with the retardation f2, and we consider in time t2 and covering distance s2, it comes at the next point B and obtain velocity 0. That is, it comes at rest finally. Okay. So at first we describe this figure. So we can write let the particle starts from point A with acceleration from point A with acceleration F1 and in time t1 covering distance Okay, covering distance S1 reaches at point C and obtained velocity v. After that, the particle moves with retardation f2 and in time t2 covering distance S2, it reaches at point B and coming to rest. Okay, here given total distance, that is S1 plus S2 is equal to S, and total time, that means total required time T1 plus T2 is equal to T. These two are given. Now we will find out these four terms, that is S1, S2 and T1, T2. In first part, that is in AC, here from here we get T1 and S1, and from second part CB we will find out T2 and S2. Okay, now to get two items T1 and S1 from first part, we apply here two formulas. So better we apply first and second. You can also apply first and third, but here we apply first two formulas. So now we can write for the distance AC, here first formula is V is equal to U plus Ft. Okay, so here V is V, U means 0, and here this is acceleration, so V is equal to U plus Ft. F means F1, T means T1. So from here we get the value of T1, and T1 is equal to V by F1. This is equation of 1. Again, now we apply second formula. Second formula is S means S1. S means S1. S1 is equal to UT. UT means 0. 0 into T means 0. UT plus half of Ft square. That means F1 T1 square. Here you can see that F1 T1 is equal to V. Okay, F1 T1 is equal to V. So if we put this value F1 T1, we can write F1 T1 means V and into T1. This is equation number 2. Side note, since, so here you can side note, since V is equal to F1 T1. This can be written as half into F1 T1 into T1. So this F1 T1 means V and extra T1. So this is equation number 2. Now for the distance CB. Now for the distance CB, at first we apply first formula, that is V. V means 0. V is equal to U minus V. Here retardation, so minus V is equal to U minus Ft. Here F2 and T means T2. So we can write F2 T2. F2 T2 is equal to V. So T2 is equal to V by F2. This is equation number 3. Already we have T1, T2 and S1. So we need now S2. Again, for S2, we apply second formula for the second part, CB. Second formula is S. S means S2. UT means V into T2. Retardation, so minus half of FT square means F2 T2 square. Now we can write V T2 minus half of, again you can see that F2 T2 means V. F2 T2 means V, so we can write half into F2 T2 into T2. So F2 T2 means V and into T2. Side note, since V is equal to F2 T2, that is S2 is equal to half of V T2. This is equation number 4. So already we got T1, S1 and T2, S2. Here there are two equations. One of them is S1 plus S2 is equal to S, and second one is T1 plus T2 is equal to T. So at first we add equation number 2 and 4. This is page number 2, adding equation number 2 and 4. We get here 2 means S1 plus S2 is equal to, here you can see that S1 is equal to half of VT1 and this is half of VT2. So we can write half of VT1, half of VT1 plus half of VT2. Here S1 plus S2, just remember here S1 plus S2 is equal to S, and at right side we can take common half of V, then we get T1 plus T2, or we can write S is equal to half of V into T1 plus T2 means T. From here we find out the value of V. Here V is equal to 2S divided by T. Now we add equation 1 and 3. Adding equation number 1 and 3, we get please look at here equation of 1 is T1 is equal to V by F1, and equation 3 T2 is equal to V by F2. So if we add this, then we get T1 plus T2. T1 plus T2 is equal to V by F1 plus V by F2, or the value of T1 plus T2 is equal to T, and here V is common. We can write 1 by F1 plus 1 by F2. Now putting the value of V, then we get T is equal to, here V means 2S by T, 2S by T, and then 1 by F1 plus 1 by F2. That is, if we transfer this term at left side, then we get T square divided by 2S is equal to 1 by F1 plus 1 by F2. This is number 1 proved. 1 proved. In question number 28, here you can see that in the book. In question number 28, there are two questions. Number 1 is T square by 2S is equal to 1 by F1 plus 1 by F2. This is required to proof. Already we have proved this. And in 2, just you can see that here T is equal to, that is now we will find out the value of T, then number 2 will be proved. Okay. So from here, if we proceed from here, then we can write T squared is equal to 2S into 1 by F1 plus 1 by F2, or we can write T squared is equal to 2S, just by LCM we can write F1 into F2, and here F2 plus F1. So T is equal to, look at here, T is equal to root over, just in proof It is required to prove that 2 into, okay, 2 into F1 plus F2 into S and divided by F1 plus F2. So this is number 2 proved. Okay, so we have completed question number 20. It is an important question, and now we go for example 3, and which is also similar to this math. Okay, now we go for, and this is page number 3. This is page number 3. Now I want to go for example number 3. Now I go for example number 3. This is the question. Example 3, you can see that. A train stopped at 2 stations 2 kilometers apart, takes 4 minutes on the journey from one station to the other station. That means the distance between 2 stations is 2 kilometers, and required time from one station to go one station to other station, from one station to other station is 4 minutes. The train describes first part of the journey with uniform acceleration x and the second part with uniform retardation y. Then prove that this it is required to prove. So same things like previous math. Such an example, A is one station and B is another station. So the initial velocity at station A is 0. Just similarly, similar to previous math, here we can see that, here we can say that in time t1 and covering distance s1, it comes at point C and obtain velocity v. Here acceleration is x, and in second part here is retardation y, and here we consider that required time from C to B is t2 and covering distance s2. It reaches at point B and it comes to the rest. That means its final velocity is 0. So just the description of this figure is similar to previous math. So now I want to drop that. Here for the distance C, for the distance AC, just using first formula we can write that V is equal to U means 0. V is equal to U plus Ft, that is x t1. From here we get t1 is equal to V by x. Here two things are given. One of them is t1 plus t2. Here total time is 4 minutes. T1 plus t2 is equal to 4 minutes. So we consider this time in minute. Okay. And total distance, that means s1 plus s2, it is 2 kilometers. Okay, it is 2 kilometers. Now this is equation number 1, and if we use second formula, that is s1 is equal to ut means 0 plus half of ft square, that means x t1 square. Then finally we can write s1 is equal to half of x t1 square. This is equation number 2. Now for the distance, CB. Now for the distance CB, similarly here V means 0 is equal to U means V retardation, so minus retardation y t2. From here we can write y t2 is equal to V. That means t2 is equal to V by y. This is equation number 3. And second formula S, here S means S2. S is equal to ut, that means vt2 minus half of yt2 square. By the similar way, here we can write, here one more line, S1 is equal to half of, here we can say xt1 means v, so here we can write half of vt1. This is equation 2, since v is equal to xt1. Similarly, here you can see that yt2 is equal to v, yt2 is equal to v, so now we can write yt2 means v and into t2. Side note, since v is equal to yt2, by subtracting, you can write s2 is equal to half of vt2. This is equation number 4. So just similar equation like question number 28. Similar equation. So now at first we will add 1 and 4. Add equation 2 and 4. Sorry, 2 and 4. Then we get s1 plus s2. Here s1 is half of vt1 and s2 is half of vt2, or s1 plus s2 is equal to half of v common, then we get t1 plus t2. Here s1 plus s2 was 2 kilometer, 2. Half of v t1 plus t2 was 4. So from here finally we get v is equal to 1. Again adding equation number 1 and 3, then we get t1 plus t2 is equal to, here t1 means v by x, here t1 means v by x, and plus t2 means v by y, or just t1 plus t2 is equal to 4, v is equal to 1, also 1, so this is proved. 1 by x plus 1 by y is equal to 4. This is the end of question number, example number 3. Just I want to give a screenshot. This was first page. Just if you want to take a screenshot, then you can take this from here. You can see full page. Okay, now I want to go for second page. So here you can see that full page is here, so you can take screenshot from here also. This is page number 2, and then I go for page number 3. You can take a screenshot of full page. Okay, you can take a screenshot from this. Okay, now we solved 2 problems here, and there are also some another problems. This is suppose 33. Okay, 33, then 30. These numbers, these maths are also similar. Just you can write down reference question number 31 and 31, 32 and 33. Question number 31, 32 and 33 are same math. So you can do this math at your home. So thank you very much. No more today. Inshallah, at next class we also solve some another problems from this chapter. Thank you very much, and be well. Thank you.